Hello, welcome to Marsh Mathematics, and today I'm going to be looking at concave and convex curves. Okay, well, the trouble with concave and convex curves is the terminology used by different examination boards. Okay, so I'm going to try and clear that up, because if you do questions from different examination boards or look at different textbooks, you might get a bit confused from this, so I'm going to try and clear that up today. I've taught MEI, OCR and Edexcel as well, and if you've seen a curve and part of the curve was shaped like this, like a maximum part, okay, like a maximum, you would say that was a concave curve, so because it looks like the entrance to a cave. Okay, that's how to remember that. But if you're doing MEI, they would say it was concave downwards. Okay, so depending on which board you use, okay, that's the two ways it will be described. Now sometimes you might get it called convex upwards, but forget that. Okay, MEI, OCR, concave downwards, or Edexcel, concave, a concave curve. And the thing to remember is that dy by dx is actually decreasing as we move around the curve. Okay, and that's why d2 y by dx squared is less than 0, just like it is with a maximum. Okay, the other type of shape of curve we look at is a convex curve. Now that's how this is how it would be described in Edexcel, but if you're doing MEI, it's called concave upwards, because the line is drawn above the curve between 2 points. See, in the concave downwards, the line between 2 points is below the curve. With this one, the red line I'm talking about, is drawn. If you draw a line between 2 points on the convex curve, it's concave upwards. Okay, so in MEI you would say this is concave upwards. Edexcel you would say it was a convex curve. But with this one, the gradient is actually increasing, and so d2y by dx squared is greater than 0. So that's all the information there for you to remember. Okay, don't worry about the convex downwards and convex upwards, just remember the stuff in black that I've written there. Okay, depending on which examination board you're doing. So let's have a look at a question that they could ask. Alright, so it says this is a graph of the graph of this function here has concave and convex sections. Okay, find the range of values of x where the graph is convex. Now this is an Edexcel question, but if it was MEI, they would say find out where it's concave upwards. Concave upwards. Okay, so that means we need to find the second derivative d2y by dx squared. So we differentiate it, and then we differentiate it again. Now for a convex curve, or convex section of the curve, okay, d2y by dx squared needs to be greater than 0. Okay, now in MEI we'd say that was concave upwards. Okay, because remember, if we can draw a line like this above the curve, okay, between 2 points, and it's above the curve, then it's concave upwards. But in Edexcel we'd call that a convex curve. Alright, so we solve the inequality and we find that x is greater than minus a third. Now that's the answer to the question. Okay, that's the range of values. But I've just gone a little bit further now to sort of go into it. So, well, when would the curve be concave then, looking like a cave, alright? Or concave downwards. That's MEI way, okay, concave. So it looks like a cave, so it's concave, or concave downwards. Because you can draw a line. When we draw a line between 2 points, it's below the curve. That's why it's called concave downwards, okay, for the MEI people. That means that d2y by dx squared is less than 0, because it's like a maximum. Okay, then we find out that x is less than minus a third. So what's going on with this curve? Well, because we're looking at the shape of curves, and the next video I will be looking at, if you go on to, you can get, I've plotted this curve on Desmos. Okay, using Desmos, and you can see what's happening here. And I've done the calculations here to find out the maximum and minimum. Now you did this in the first year, you should have done, you know, finding out when dy by dx is equal to naught, finding out the x values, okay, and then finding the second derivative, and we find out when x equals a third that d2y by dx squared is greater than naught, so it's a minimum, and when x equals minus 1, d2y by dx squared is less than naught, so it's a maximum. And anyway, you can see it from the plot on the curve, okay? You can see that we've got a maximum here and we've got a minimum, and in between the two of them we have something called a point of inflection. Our point of inflection is when d2y by dx squared is equal to naught, okay, and that has just come from 6x plus 2 equals naught, and so x equals minus a third. Okay, so in the next video we'll be looking at this, and you can see that this is the point here, minus a third. We've gone from a maximum to a minimum. We've gone from concave upwards to concave downwards, or from a convex curve to a concave curve, and this point here is called a point of inflection, and this is when d2y by dx squared is equal to naught. Okay, when x is greater than minus a third, it's concave upwards, and when it's less than minus a third, it's concave downwards. Okay, so that's all for now, but in the next video I'll be looking more at points of inflection and stationary points of inflection.